All right, here we are. Looks like it's completely through hole. That's not too surprising. I think this product has been on the market since either the mid 80s or early 90s. So there's really no need for them to respin the board, especially if they know it already works. They have a high enough profit margin so that cost isn't really too big of a problem for them. Okay, so here is a view of the inside construction. So we have a mains IAC input right here. It looks like it is not configurable, actually. The input voltage range is not configurable. So this unit is only to be used in countries that have around 120 volts mains. So it goes through a step-down transformer. Very obvious. You see 3 wires coming out. That obviously means that the center wire is a center tap. So they're using a split supply. Very common in these kind of products. We have a separate display board right here, which is interesting. That's what I would do if I was to design something like this. If it had some sort of display, that's a perfect solution for that. That board's also through hole. I don't see a single surface mount component on this. But again, that's not very surprising. So you can trace the mains that comes in here. Has a nice dedicated lug, a nut that goes to the chassis. Looks like the paint has been removed, and that's the proper way of doing it. So this is a great design so far. I don't know if you can see here. Let me zoom in. Let me zoom in for each little section, and we can talk about it. I'm not 100% sure on all of this, but I've seen these kind of things a million times, so I think I'll be pretty close. The center tapped transformer comes in here, plugs into the board here. I see 2 little ceramic capacitors. That's obviously hash filtering to get rid of some of the high frequency noise before it goes through a full bridge rectifier. They're using individual diodes there. A lot of times it's cheaper, especially if you're using those diodes on other products. Goes into 2 filter caps for the positive and negative supplies. Another ceramic cap, and looks like there's a star ground right here with vias. So maybe this board is 4 layers, but I still doubt it. These 2 guys right here, I can bet you, are linear regulators. Very nice heat sinking solution. This is definitely what you want to see. You don't want to see the TO220 packages just standing up by themselves. This is a great solution. Vibration is not going to be an issue, even for shipping this. Some more ceramic filter caps on the output. Interestingly enough, there are 2 more diodes, and then 2 capacitors. Plus minus 15 volts. There's a silkscreen label right here. Interesting. So plus 15, minus 15 in the ground. In between, I'm not exactly sure what component would be here. M2 and M3 are the reference designators. If you see, very interestingly enough, they're using Q for the reference designator for these BJTs right here. So most likely those are probably a MOSFET of some type. I don't see any other MOSFETs on the whole design, so we can't really refer to that as being the case. Let's see. So we have, interesting, we have an unpopulated connector here. Maybe there's another version with with 2 channels maybe? So there's 2 ribbon cables that go to 2 different boards? I'm not sure. Let's keep going. Okay, so we have the 2 BJTs here. That could be for more regulation. I'm not exactly sure. So I don't see really anything else for this main power supply section. I see 2 resistors here, some capacitors, some Zener diodes, interestingly. Actually, there's quite a few Zener diodes around. That's interesting. I would assume that they're used for maybe a voltage reference. I'm not quite sure. So the power supply is always easy. I'm actually going to go from the input jack and trace my way to the output jack, because sometimes you can get kind of lost looking at someone else's layout, because this is very unique in its functionality. Okay, we have the 1/4 inch input and also the XLR input. It looks like the 1/4 inch input, the trace is on the bottom side of the board. Based on this configuration, it looks like this is an op amp of some sort. Some filter caps. This is interesting right here. This is actually a thermistor. I don't know why it's over there. Maybe they just, a thermistor. They have 2 of them. I don't really know why they're using those. Actually, looking at it, there's a bunch of them. There are like 5 of them across the board. So maybe they're using some kind of temperature compensation. I wouldn't expect it to be that sensitive. For audio, that doesn't seem very important. That's strange. So we go from this DIP 8 package, which is clearly an op amp. And there's a single inline package here. It actually says DBX on it. So they either relabeled an off-the-shelf part, or they really do have an integrated circuit that they fabricated. I don't know. So I'm sure there aren't too many copies on the market, given that they're using potentially custom integrated circuits. So after this op amp here, I see a trim pot. It says offset trim. So this circuit right here must have something to do with the offset. I'm not sure. This is actually a relatively tricky layout. So what I'm going to have to do, I need to be able to see the bottom side of the board to really know what's going on, because there aren't too many traces up on top. Okay, it's out. Here's the board. Not surprised. There are no components on the bottom side of the board. Ta-da! Now, let's see if it's a 4-layer board or not. You just hold it up to the light. Hopefully you can see that when you hold it up to a light, you can't see any copper inside of the board. Alright, so here's the input. Like I was saying before, these two connectors. You can choose which one you want to use. So, let's see what's really going on with the signals here. Okay. So if I turn the board over, you notice that, interestingly enough, the other side of the board doesn't have a pour. Typically you would actually want to fill the bottom side of the board with a ground plane where the traces aren't, but yeah. You can tell a person routed this. It looks very nice. Whoever did this did a pretty good job. Let's trace this out. So we know that for 1/4-inch jacks, the tip is always a signal. The sleeve is always ground. And then the ring, if there is one, is also signal. So this looks like it can accept a balanced input signal. You can see because it's TRS, tip, ring, sleeve. I didn't look close enough to know before. These aren't regular inductors. They look like actual a different or a common mode choke. So any noise that's present on both signals is eliminated. So you have this cable. You have this cable with 2 signal lines on it. What happens if noise gets into that cable? It usually comes on both lines equally because they're routed together. So let's say you have the same noise on 2 lines. Anything that's not differential will be shunted to ground through these inductors. So very cool. I haven't seen that technique used for audio all too much. So we have this thermistor here. I want to see what that does. Okay. So it ties to this trace right. It ties to this trace right here and this trace. So this switch right here connects to one side of that thermistor. Wait, what in the world? It's not doing anything. Because you can see, those 2 terminals are shorted together. What? That's weird. those two terminals of that thermistor are shorted together. So it's in parallel with a trace. Okay. Not sure. The signal also goes down this way. So let me trace this out. It goes to this connection right here. And if I flip the board over, very interesting. It goes to the pin, one of the pins on the unused connector. What in the world is going on here? The only thing I could think of. What? The only thing I can think of is this is some kind of burn-in test where they actually read the temperatures across different parts of the board when they're putting it under stress to make sure it's evenly distributed. I don't know. That's weird. Never seen that before. This guy right here. Let's read the part number. It's a NE5532AP 35A1C4M. It's a Texas Instruments part. I'm gonna go look that up. Make sure it's an op amp. All right, so I just looked that up. Right here on my phone, I looked that up. It is a dual package op amp. So it is. It requires ±5 to ±15 volts. They're using the ±15 volts, as you should, to get more headroom for your signal. It has reasonable input offset voltage ratings. 10 megahertz gain bandwidth product. That's pretty good for an audio op amp. Slew rate 9 volts per microsecond. 200 nanoamps input bias current. So these are pretty decent specs for audio. And it's only $1.10 in one quantity of 1. So it's cheap. It's just nothing special about it. Classic example. You should identify this. This is a classical way of laying out the power traces. So you have one rail that goes across the whole board, and then the other rail goes across the board as well. And in a split supply system, that's the best way of doing things. So the whole pour on the top side of the board is ground. 44.5 ohms between the center pin of this connector and the star ground. That shouldn't really be the case. I wonder if there's something wrong with my probes. Yeah, there is. The sleeve on the connectors are connected to ground, which is exactly what you would expect. Now on the back to the op amp, what pin's connected to ground, if any? Let's see. None. And in true fashion of a split supply, that makes sense. So if I look at the silk screen, we have an offset trim adjust here, a VCA system, VCA SYM. That sounds like it's a voltage controlled amplifier. Voltage controlled amplifier symmetry, potentially. So this op amp is doing some fancy business with the voltage being a VCA. We do have we do have room for a transformer here. Obviously, they're just using 2 resistors in place of it. That's probably for a higher end model that has impedance matching on the output or the input, I don't know. Infinity calibration. So this does have a quote-unquote infinity compression ratio that you can select. So they're doing some kind of magic there. And oh, that goes back to, most likely they're using the Zener diodes to do something with that. All right. What other? Oh, that's interesting. These potentiometer cases are actually magnetic. Huh. Oh, anyway. So we have gain calibration, threshold calibration. And they're using more TI parts here, Texas Instruments. I'm going to look up these 2 part numbers and see what that's about. My guess is it's probably a quad op amp, but let's check. But before that, and there's also RMS system, or RMS symmetry. And that's probably RMS. Okay. So they must be doing some kind of true RMS reading to measure the power of the signal. It's very common in communication systems or in radio frequency amplifiers to do true RMS readings. So that TI part number is TL 074CN. And interestingly enough, that is, yep, that is an operational amplifier, just like I thought. It's a 4-circuit JFET amplifier, 65 cents each if you buy one, 27 cents if you buy 1,000. Wow, so that's cheap. Wow, not bad. 65 picoamps input bias current. All the magic they're doing is really by using standard parts, which is more impressive, actually. Yep, this whole thing is op amps, so truly I wouldn't be surprised if this entire board is just analog circuitry. Just so happens that they have some kind of special sauce going on. But it makes total sense. Interesting. But like I said, the build quality is actually quite good. The attention to detail is nice. I still don't know what the thermistors do. But those chokes are very, very nice touch. I'm happy to see that in here. And I don't doubt that this quality construction is really going to enable this thing to last for a very long time. The only concerns I have, well, the only problems you'll probably have are these 2 input capacitors. They'll probably leak over time because they're electrolytics. And then there are a couple other electrolytics, and those are probably going to be your only problems. But not a bad construction. I would definitely give it a thumbs up. There are a couple things here and there that could have been improved, but it's really not too bad considering this is an old design. Let's take a look at the display board and also the well, there are 2 display boards. I'm actually not even going to bother taking these display boards out because it's super simple. They just have an LM339 on this display board, and this displays the clipping whether it's below, above, or over easy is what they call it. Well, all that means is the compression on or not? That's really what it's showing. And the other display board, this actually shows the levels, how much gain reduction you have, and the input or the output level, depending on what you if you press this button in or not. Not very surprising that there's just more LM339s, LED drivers. I mean, it's pretty boring. Same kind of deal there. Overall, I'd rate this product probably an 8 out of 10. It's quite expensive for the parts they're using. However, there's no denying that it works very well. All right. One more thing has to be said before I go. The quality of the connectors they use is actually very nice, and they're not skimping on them. I mean, some of them have some plastic parts, but they have metal cases that the screws screw into. A lot of these electronics products, they usually have screws that just go into plastic, and if you take it apart, it's just not going to go back together very well. But really nice touches. See ya.